Welcome to the deep dive. Today we are diving into LLMs, those AI systems that can write poems and code and answer your questions like instantly. We're asking, can they actually become truly intelligent, like really intelligent?
Yeah, that's the big question. I mean, the answer, at least for now, is not quite. Current LLMs are incredibly powerful, but they're more like specialized wizards,
Yeah.
masters of language. But true intelligence, what we call AGI, it's much broader. It's about adapting to new situations and solving different kinds of problems, maybe even having a sense of self.
Yeah.
And that's something that LLMs aren't quite doing yet.
So if current LLMs are these language wizards, what spells are they missing to become truly AGI? Our research notes point to some pretty interesting areas where researchers are really focusing their efforts. One that really caught my eye was this idea of embodiment.
Embodiment. Yeah, it's a fascinating idea. True intelligence might actually require interacting with the physical world, not just the digital one. Think about it, you learn about gravity not by just reading about it, but by experiencing it, maybe taking a tumble as a kid. So giving LLMs something like a robot body could allow them to experience the world through senses, things like sight and touch and sound.
Okay, so it's like giving our language wizard a set of robot eyes and ears and hands so they can experience the world firsthand.
Yeah.
I can see how that could lead to like a much deeper understanding of how things actually work.
Exactly. Embodied cognition that could let LLMs actually learn through real-world interaction instead of just processing text. So they could experiment, make mistakes, adapt, just like a child learning to ride a bike.
But what about those of us who aren't quite ready for a world with AI robots roaming around?
Yeah.
I mean, are there other ways to kind of bridge this gap between the digital world and the physical world?
There are. Simulated environments are another exciting avenue. Researchers are building these really detailed virtual worlds where LLMs can learn and experiment without the risks of, having physical robots.
So like a giant, super realistic video game where LLMs can kind of play and learn about physics and cause and effect and maybe even social interactions.
You got it. It's a safe space for them to experiment and learn. But even with embodiment, there's another huge hurdle. Moving beyond just pattern recognition to true understanding.
What do you mean by that? I thought LLMs were already amazing at finding patterns.
Oh, they are. They are. But think of it this way. They're great at recognizing the patterns in a love song, but they don't actually feel love. They don't grasp the deeper meaning, the emotional context. It's like they can tell you the definition of happy, but wouldn't understand what makes you happy.
So how do we bridge that gap? How do we teach an AI to actually understand something like happiness or any abstract concept?
Well, one promising approach is called neurosymbolic AI. It's like combining the strengths of two very different AI approaches. You have neural networks, which are great at learning patterns, and then symbolic AI, which excels at logical reasoning.
So it's like giving them a brain and a mind.
Precisely. This could allow LLMs to learn both statistical patterns from data and explicit knowledge, like facts and rules. And that combination could lead to a much deeper and more meaningful understanding of the world.
Okay, so embodiment and deeper understanding, those are two big pieces of the puzzle. What else is crucial for an LLM to make the leap to AGI?
Well, think about how you learn. You don't just memorize facts. You constantly update your knowledge and you build on what you already know. Right now, LLMs have a kind of fixed memory based on their initial training data.
So they're like students who cram for a test but then forget everything the next day.
Right.
That doesn't sound very helpful for achieving true AGI.
Exactly. That's why dynamic memory is so important. We need systems that can continuously learn and adapt, integrating new information seamlessly, just like you do.
I can see how that's important. But wouldn't that require a ton of memory capacity? I mean, think about how much information we accumulate throughout our lives.
It's a challenge, but there are some fascinating ideas out there. One is called memory palace construction. It's inspired by these ancient memory techniques where you associate information with like vivid mental images in a familiar place.
Wait, I've heard of that. People use it to memorize speeches or long lists. It's like creating a mental map of a library, right?
Exactly. And applying this technique to LLMs could allow them to store these vast amounts of information efficiently and then access it quickly when needed.
That would be like giving them a mental Google search, instantly pulling up any piece of information.
It would be incredibly powerful. And it's not just about storing everything. LLMs would also need to learn how to prioritize and filter information, focusing on what's most relevant, just like our brains do.
So they're not just hoarding information, they're actually learning to think critically and focus on what matters.
Precisely. And this ability to prioritize is closely linked to another essential element of AGI world modeling.
Okay, now you've really lost me. What is world modeling?
Think of it as creating an internal simulation of the world, a mental model that includes physical laws and social rules and cause and effect relationships.
So like building a miniature replica of the world inside their digital brains.
In a way, yes, this world model would allow AGI systems to make predictions and plan actions and understand the consequences of those actions, all without needing to interact with the physical world directly.
That's amazing. But how do we actually build these incredibly complex world models into LLMs? Wouldn't that be a huge undertaking?
It would be. And researchers are exploring different approaches. One promising avenue is to integrate physics engines and causal reasoning modules into LLMs. These tools could allow them to run simulations and learn about the consequences of different actions, almost like a virtual physics lab.
That's fascinating. But to truly understand our world, wouldn't LLMs need to go beyond just text and incorporate other senses like vision and hearing and touch?
Absolutely. That's where multimodal sensory integration comes in. Imagine an LLM that can not only read about a forest, but also see its vibrant colors and hear the rustling leaves and feel the rough bark of a tree.
Wow, that would give them such a rich and nuanced understanding of the world. It's almost like giving them the full human sensory experience.
Exactly. And this multimodal understanding, combined with a dynamic memory and a sophisticated world model, could take us a big step closer to true AGI. But there's still a long way to go.
This is all so fascinating, but I have to admit it's a lot to wrap my head around. We've covered so much ground already, from giving LLMs robot bodies to building virtual worlds and creating mental Google searches. Where do we even go from here?
Well, we've talked about what AGI needs to have the tools and abilities, but what about how it learns? That's where things get even more interesting.
Okay, I'm all ears.
For true AGI, we need systems that can learn and adapt autonomously without constant hand-holding from humans. And that's where these self-improving meta-learning algorithms come in.
Meta-learning. Okay, you're going to have to break that down for me. It sounds pretty high level.
It is. Think of it as learning to learn. So imagine an AI student that not only studies the material, but also figures out the best study methods for itself. It can analyze its own learning process, identify what works and what doesn't, and adjust its approach accordingly.
So they're constantly optimizing their own learning strategies. That's pretty impressive.
Yeah.
But wouldn't that require a really deep understanding of how their own brains work?
It would, and that's one of the key challenges that researchers are working on right now. Techniques like differentiable plasticity are showing some promise. It's a mouthful, I know, but essentially it allows the AI system to fine-tune the connections in its neural network based on its own experiences, makes it a more efficient learner.
It's fascinating how these concepts are kind of inspired by the human brain. We're basically trying to replicate the brain's incredible learning abilities in these artificial systems.
Yeah, we are. And another crucial area of research is causal reasoning. Right now, LLMs are great at spotting correlations in data, but they don't always understand the underlying cause and effect relationships.
So they can tell you that people buy more ice cream when it's hot outside, but they wouldn't understand that it's because people want a cold treat on a warm day.
Exactly. Teaching AI to understand why things happened is essential for them to make informed decisions and understand the consequences of their actions and solve problems that require more than just pattern matching.
It sounds like we're asking a lot of these AI systems. We want them to have bodies and understand abstract concepts and learn on their own and reason about cause and effect. It's like training for a mental Olympics.
It is. And that brings us to another critical piece of the puzzle. How can these systems handle the vast amounts of data needed for true AGI, especially when that data might be spread out across different locations and organizations?
That's a great point. We've talked about building these dynamic memories, but even the most sophisticated memory system can only hold so much information. And with data privacy concerns on the rise, pooling all that data in one central location might not even be feasible.
Exactly. That's where the idea of federated learning comes in. Imagine a network of hospitals, each with its own valuable patient data. Instead of sharing that sensitive data directly, which could raise privacy issues, federated learning allows an AI model to train on data at each location without actually seeing the raw data itself.
So the AI travels to the data, not the other way around. That's pretty clever, but how does it actually work?
It's a bit technical, but the basic idea is this. Each hospital trains a local copy of the AI model on its own data, and then they only share the updates to the model, the lessons it's learned, with the central server. And the central server then combines all these updates to create a global model that's much more powerful and accurate than any single hospital could achieve on its own.
It's like each hospital contributes its own chapter to a book, and together they create a comprehensive encyclopedia of medical knowledge. And the patient data never actually leaves each hospital, right?
Exactly. Federated learning is a game changer for training AI on sensitive data, and it has huge potential beyond healthcare as well. Imagine AI models learning from environmental data collected by sensors all over the world, or financial data from different institutions, all without compromising privacy.
It's like creating this global network of AI learners, each contributing its own unique perspective to a shared pool of knowledge. That's an incredible vision for the future of AGI. But it also raises some interesting questions. For example, if we have all these different AI systems learning and evolving independently, how do we ensure that they're still working toward the same goals? How do we prevent them from diverging or even conflicting with each other?
That's a crucial question. And it leads us into the realm of AI alignment. As these systems become more sophisticated and autonomous, we need to think carefully about how to align their goals and values with our own. We need to make sure they're working with us, not against us.
It's like the classic sci-fi dilemma.
Mm.
Will robots help us or harm us? I know we're trying to avoid getting into like ethical discussions here, but it feels like we're tiptoeing around some pretty big issues.
We are, but the point is we need to be proactive about addressing these concerns. We can't just wait for problems to arise and then try to fix them after the fact. We need to build safeguards into the very foundation of AGI development, ensuring that these systems are aligned with human values and goals.
So how do we do that? How do we teach an AI system about values like compassion and fairness and respect?
It's a complex challenge, and there's no, of course. Differential privacy essentially adds a careful journey that we're all on together.
It's amazing to think that we're having these conversations about AGI.
Hmm.
Now, it used to be pure science fiction, but now it feels like we're on the cusp of something truly groundbreaking.
It is a remarkable time to be working in this field. The progress we've seen in just the past few years has been astonishing, and the pace of innovation is only accelerating.
It's like we're witnessing a technological revolution unfold right before our eyes. But it's also a bit overwhelming, to be honest. There's so much to learn and so many potential paths forward. It's hard to know what to focus on, what's most important.
I understand that feeling. It's a vast and complex field.
Those are big questions, and I don't think there are any easy answers. It's going to require a lot of careful thought and open discussion.
It will, and it's not just a discussion for scientists and engineers. We need input from philosophers and ethicists and policymakers and everyday citizens. The future of age us to redefine what we mean by intelligence and consciousness, perhaps even blurring the lines between human and artificial.
It's a bit mind-boggling to consider, but also incredibly exciting. It feels like we're on the verge of a new era of exploration and discovery, not just in the scientific realm, but in the realm of self-understanding as well.
I agree, and I believe that the pursuit of AGI, if approached thoughtfully and responsibly, has the potential to not only solve some of the world's most pressing challenges, but also to deepen our understanding of ourselves and our place in the cosmos.
It's an inspiring thought, and it's a reminder that the quest for AGI is not just about technological progress. It's about expanding the boundaries of human knowledge and pushing the limits of what's possible.
Beautifully said, and as we continue on this journey, let's remember to approach it with curiosity, humility, and a deep sense of responsibility for the future we're creating.
Well, that brings us to the end of our deep dive into the world of AGI. It's been an incredible conversation, and I hope you, our listeners, have found it as thought-provoking as we have.
It's been a pleasure sharing these insights with you, and I encourage everyone to continue exploring, questioning, and engaging in the conversation about AGI.
Thank you for joining us on this episode of The Deep Dive. Until next time, keep learning, keep questioning, and keep pushing the boundaries of what's possible.